Okay, let's take a look. How do we do this one? So we're trying to find absolute extrema. This is good practice. Finding critical points that give us an interval. What do we got to do here?
Take the derivative.
Take the derivative, right? Okay. So we need a derivative. So this is kind of an ugly derivative to take. It's the derivative of the first term. What's the derivative of 4x squared? Okay, second term. We got to do the derivative of arc sine. So somebody remind us here. What is our derivative? If we're let's write down our standard form. The derivative with respect to x of inverse sine of u is what? Remember that?
U over
Well, u
U
prime
prime
over,
square root of 1 minus U squared.
there you go, u prime over square root of 1 minus u squared. One we don't use very much, but there's the form. Okay, so then if we're going to apply that, we've got our 4 out front, right, plus 4 times, we've got the arc sine of x. So what's u prime in this case? 1, right? So I'm going to get 4 times 1, so 4 divided by square root of 1 minus x squared, right? Okay? So we want to find all critical numbers. Okay, so critical numbers would be where? Where the derivative is undefined or 0. So where would the derivative be undefined?
Are you recording?
I am recording, yes. Okay. So let's organize our search here. So if we're looking for critical numbers, we know that f prime is undefined at what? What's going to be the flag that we're going to see here? Where would things be undefined? Where there's two things, right? Where we take an even root of a negative number, or we divide by 0, correct? Okay. So then, here's the argument of our square root. Okay, so this is good practice here. I think everybody ought to pause for a second and just take a look at this issue. I think this is something that'll be helpful to you. Kind of a non-calculus issue, but good math. So the argument of the radical has to be non-negative. So everything in the blue bubble, everything inside the square root, we'll just write it as a blue bubble, has to be what then? How do I say that has to be non-negative? Non-negative is not the same as positive.
0 with the plus of.
Okay, so greater than or equal to 0, right? Because the square root of 0 exists, that's 0. So then what is in here? We get a 1 minus x squared. So what that gives us then, when you think of it that way, whatever's the argument of the radical has to be greater than or equal to 0. It just gives you an inequality that you can solve. Okay, so how would we solve that? Okay, move x squared to the other side, and we get x squared is less than or equal to 1, right? Now what? Square root both sides? Okay, if I square root both sides, and here's an instance where it really is helpful to not hide the missing steps when I'm solving a quadratic. I'm going to square root both sides. And what is the square root of x squared? No. Absolute value of x is less than or equal to, well, it's less than or equal to 1. Okay. Now think back to when we solve an absolute value inequality of this type. If I have an isolated absolute value that's less than a number, that becomes an and compound inequality, right? Because really what this means is the distance between x and 0 has to be less than or equal to 1, right? So it's got to either be, it's going to be bound, that distance is bound between positive 1 and negative 1, right? So then this becomes x is less than or equal to positive 1, and greater than or equal to negative 1. Typically we'd say it the other way around. Okay? That make sense? So those are the places where it's defined, I should say, right? F prime is defined at. So it's undefined everywhere else, but look, those are on my interval. Right? So we're okay. The other place would be, so it's defined where the root is greater than or equal to 0. Okay? We could have done it the other way and said it's undefined when 1 minus x squared is less than 0. That would have been fine too. Could have solved that inequality. But it's also, there's two places. F prime is undefined at whenever the bottom is equal to 0 also, right? We've got two separate things going on. So the bottom is 0 when 1 minus x squared equals 0, which is when x squared equals 1. Okay, so it's undefined then at x equals plus or minus 1. So this is an important question. Do those count as critical numbers? They don't. You're right, because we're only looking for critical numbers on the interior of our interval. Endpoints don't count as critical numbers. We're going to test the endpoints anyway, right? So are there any critical numbers on an interval? No, there aren't any. Okay? Make sense? Okay.
No, this isn't.
No.
Oh, hang on. No, we didn't. So there aren't any places where it's undefined. We got to look for the other kind. Yeah. So what's the other kind? Where it equals 0. So we haven't done that yet. So f prime equals 0 when this expression equals 0, right? Or when this expression equals 0. So when 8x plus 4 divided by the square root of 1 minus x squared equals 0. So this is some kind of good math too. This is sort of fun math here. We got to solve that. Radical equation. So what would we do? Okay, move 1 to the other side. Okay, so let's just move this guy to the other side. So we get 4 over the square root of 1 minus x squared equals negative 8x. Now what? What can we do? Okay, we could cross multiply, but what's our goal when we're solving a radical equation? What are we trying to get, what step are we trying to get to next?
Get rid of it.
Okay, but how?
Square.
Think back, this is something you would have done, probably Algebra 2 would have been when you did a lot of this stuff. What do you think?
Can you like break it up?
What do you mean?
Like square root of 1 minus the square root of x squared?
Mm-mm, can't do that. That's not a property of square root.
I'm making it.
Okay, your goal is, when you're solving a radical equation, is you want to isolate the radical, right? How come? If I isolate the radical, what could I do to both sides to undo the radical? Square it. Okay, so we want to isolate the radical. So there's a property, and this is kind of a good thing to know too, just a little sidebar here. If I have a proportion, what's the math I can do with proportion? I could cross multiply and then divide, but you can eliminate a step. This is a good one to remember. I'm free to exchange diagonally. Isn't that just equivalent to cross multiplying and dividing, 2 steps in one? So we could do this. We could just exchange, because I got a 1 on the bottom over here, right? I could just exchange elements diagonally in this proportion in one step. And then I would end up getting the square root by itself. The square root is equal to 4 over negative 8x, which would just be the same thing as 1 over negative 2x if I reduce the fraction. Okay? And then I'm going to square both sides. Okay, but if I square both sides of an equation, this is important. If I square both sides of an equation, or I take both sides to any even root, remember that I could introduce extraneous solutions. Okay, it's a valid step, but you got to always check to see that your solutions aren't extraneous, that they work in the original equation. Right? Real important. So I'm going to change colors to indicate that we've just done something significant. So if we square both sides, we're going to get 1 minus x squared equals 1 over 4x squared. Agreed? Okay, now we'd have to, once again, cross multiply, right? Because we want to write this as a polynomial that we can factor. So if we cross multiply, we're going to get 4x squared minus 4x to the fourth equals 1. And so, let's go to the next page. So let's write that as a polynomial in standard form. So we'll maybe push everything to the other side and get 4x to the fourth minus 4x squared plus 1 equals 0. So is this one that we could factor? Is it one we could factor? In other words, could we find magic numbers that multiply to AC and add to B? Numbers that multiply to 4 and add to negative 4? What would they be? Negative 2 and negative 2. So if you can find magic numbers that multiply to AC and add to B, it guarantees it's going to factor. So let's factor by grouping. Instead of, we'll do good practice from the other day, right? Instead of using bottoms up or slip and slide, we'll do this rigorously. We'll just factor by grouping. So we're going to split the middle term. We're going to split that middle term into minus 2x squared minus 2x squared plus 1, and we'll just go ahead and split this thing down the middle, right? What's the greatest common factor of the first group? 2x. Leaving us with everybody agree? Oops, I gotta do that in red though. I think I can do this. Let me try this. Oh, that's not gonna work. I go. Ah, nice. Okay, I didn't know I could do that. That was good. So then we're gonna do plus, right? We want to add the two groups. Plus, I know I've got to have the same leftover factor here. So what do I have to factor out to make that happen? Negative 1. Okay, so now if we factor out our common leftover factor, this is equal to 2x squared minus 1 times 2x squared minus 1. So it's equal to 2x squared minus 1 squared, right? Okay, and now I'm trying to find zeros, correct? So if we set that equal to 0 and solve, that's equal to 0 when what, x squared equals 1/2?
Yeah.
Agreed? So x would equal plus or minus the square root of 1/2, which would just be 1 over root 2, or the square root of 2 over 2, right? Whichever way you want to write it. Okay? Are those good solutions? Maybe. We got to check. We'd have to go back and check in the step prior to squaring both sides. So the pink equation here. See if that works. If I plug in, we got to try both of these. So we had x equals plus or minus. I'm going to write it as 1 over radical 2, so it's easier to see what's going on. So if I try plus the square root of, or plus 1 over the square root of 2, I'm going to get 1 minus 1/2. Agreed? And on this side, if I plug that in, I would get the result, the square root of 1/2, so 1 over the square root of 2 equals, what about over here? I'd get 1 over 2 times the square root of 1 over 2, so that's not going to work, is it? I thought it would. Oh, no, it does. It does work. It does work, because look, I'm going to get, positive's not going to work. Because on the right side, I would get 1 over negative 2 times 1 over radical 2, which is the same thing as 1 over negative radical 2, so it doesn't work. Okay? It's not equal to negative 1 over radical 2. So we gotta cancel that one out. It doesn't work. The positive one does not work. What about the negative one? Negative one's gonna work. If I plug the negative one in, the negative 1 squared makes it positive, right? I get negative 1 over radical 2 squared is still 1/2. So on the left side, I still get the square root of 1/2. On the right side, what's gonna happen? That's gonna be a negative. Negative times negative is positive. And so I'm gonna get 1 over square root of 2. So it does work. So I get only one critical number at the negative value. Well, that's a lot of work.
Yeah.
Ulissa Cruz, please come to the office.
So our only critical number
Ulissa Cruz, please come to the office. Thank you.
is x equals negative 1 over square root of 2. Say it again? Yeah, but the rest of it now shouldn't be too bad. Now the absolute extreme, we just make a table with only the x row and the f row, right? And see what's the biggest value, and you can plug them in the calculator to see. Okay, we'll look at that, start a class tomorrow, and then, who's gone tomorrow? Oh, wow.
Oh, I am.
Is that band stuff tomorrow?
In choir.
And choir? Okay.
No, we're doing